All right, this is Ubaid on behalf of V Electronics, and in this video, we're going to be talking about descriptive statistics. Okay, now when it comes to descriptive statistics, or descriptive stats, this has to do with numerical and graphical ways of showing or representing data. Okay, so this is numerical or graphical ways of showing or representing data. Okay, so if you have a given set of data, descriptive statistics has to do with graphing that data. It has to do with table of values, for example. Okay, different ways to show your information, different ways to organize and show your information so that way you can analyze that data. Okay, a statistical graph, okay, this is a shape or distribution of a sample. Okay, statistical graph. Okay, we know that a sample has to do with the part of the population that is being surveyed or studied, for example, in a given experiment, okay, or to analyze something. Okay, so in this case, your statistical graph has to do with a shape of distribution of a sample. Okay, this is shape or distribution of a sample. All right. Now, when we talk about shape or distribution, all right, you have different ways of summarizing and organizing data. All right. So one of those ways would be your dot plot. All right, and if you talk about a dot plot, we're mainly talking about a graph that looks something like this. Okay, so say, for example, you have a dot over here, you have your y and x axis, you've got a dot over here, you got a dot over here. Okay, this corresponds to a x value, okay, a value on your x axis, that is. Okay, and this corresponds to your y value. All right, so on and so forth. So this is your dot plot. Now, apart from your dot plot, you also have your bar graph. And we know that bar graphs are often used for comparison purposes. Okay, whether you're comparing data from past few years or whether you're comparing data relevant to different individuals or different animals or different birds, so on and so forth. So graphs. Okay, and your bar graphs look something like this. Okay, you've got your bar over here. another bar which may be higher than the first one, the third one which may be lower than the second one, okay, so on and so forth. So this is your bar graph, and again, this is used to summarize data, information. All right, apart from your bar graph, you also have a histogram. All right, now often you would be given a range, okay, for which you have to show values. All right, so let's say, for example, you have your age ranges over here and their insurance premiums. So when it comes to your age, let's say people who are anywhere between 20 to 30 years of age, they might have a certain amount of insurance premium to pay based on their rate. So they might have a certain rate. Okay, people who are between 30 and 40 years of age, they might have a certain rate. People who are between 40 and 60 years of age, they might have a certain rate. So we're talking about insurance premium rates over here, for example, and this is where a histogram kicks in. All right, so let's say between 0 and 5. Okay, so you got 0 to 5. Okay, your histogram may look something like this, similar to your bar graph. Okay, where this is your premium, let's say $200. Okay, so on and so forth. Okay, per unit. Okay, whatever that unit might be. Okay, and then you have, all right, you have, let's say 400, okay, so on and so forth. So this is what a histogram looks like. Now, apart from a histogram, okay, you also have a steam and leaf plot. Okay, so let me draw that one out. So this is your steam and leaf plot. So steam and leaf plot. Now, when it comes to your steam and leaf plot, this is what the steam and leaf plot looks like. So it has to do with your whole numbers. So let's say, for example, if you have 25, okay, your steam would be all the numbers apart from the last number, the final significant digit. Okay, so in this case, this is 2. This will be your steam, and your leaf will be 5. Okay, if your number is 252, okay, your steam will be 2 and 5. Your leaf will be 2. All right, if it's 2520, okay, your steam will be 2, 5, and 2, and your leaf will be 0. All right, so this is basically how your steam and leaf plot works. And when it comes to your steam and leaf plot, okay, this is to present your quantitative data in a graphical format. Okay, so if you have quantitative data such as height, okay, could be weight, okay, measuring weight or height, okay, so on and so forth. Yeah, let's say you're trying to figure out insurance premiums or body mass index based on your weight and your height. Okay, so in this case, this would be BMI, body mass index, for a certain experiment, certain study. Okay, let's say for a certain clinical study for a medication. So in that case, this is your steam and leaf plot that comes in handy. All right, now apart from your steam and leaf plot, you also have your frequency polygon. So this is your frequency polygon. Now, when it comes to your frequency polygon, okay, this is more like a line graph. Okay, just like you have your line graph over here. All right, and this has to do with your frequency polygon. Now, apart from your frequency polygon, you also have, okay, your box whisker plot. Okay, your box whisker plot. And when it comes to your box whisker plot, okay, this has to do with how far the extreme values are from the rest of the data. Okay, how far the extreme values, how far the extreme values, the extreme values are from the rest of the data. All right, so this is your box whisker plot. Apart from your box whisker plot, okay, you also have, okay, your pie chart. All right, and before we move on to pie chart, let me show you what this box whisker plot looks like. All right, so let's say, for example, okay, you have something like this, and you have a vertical line. And we'll talk about the box whisker plot in another video. All right, so let's say, for example, you're trying to figure out temperature, and let's say you have extreme weather outside, and you want to figure out how far the temperature is from the regular temperature that you may have experienced in the past few days or past few weeks. Okay, so this has to do with extreme weather. And this is the reason why you might need a box whisker plot. Now, apart from a box whisker plot, you also have your pie chart. Now, your pie chart has to do with proportions, so percentages. And usually a pie chart is used when all the proportions add up to 100%. Okay, so let's say, for example, this is 45%, this would be 5%, and then the rest is 50%. So as long as they add up to 100% and you're trying to figure out the proportion of something or show the proportion in a graphical format, okay, this is your pie chart that you might want to use. Now, apart from your pie chart, you also have, okay, your box plot, okay, and we'll be talking about our box plot, okay, in one of the other videos. All right, so that would be it. Okay, as far as graphical representations are concerned, on behalf of V Electronics, this is Ubay. Have yourself a great day.